Grade 12s. What we're going to do in this little learning block is we're going to be looking at page number 9, which is just an introduction to basically an oxidation reduction activity. Okay, I'm going to do a little demo for this reaction in the tutorial that I'm going to host this afternoon. So if you have a look at this, make sure you go through the sheet, and then I'll be able to answer some questions, and I'll show you what the demo looks like. Okay, just to back it up for a second, there is quite an extensive lesson that we're going to skip over this year. It has to do with balancing using half reactions, but then also accounting for whether that reaction takes place in an acid solution or a basic solution, because if that's the case, there's either going to be some hydrogen ions floating around or some hydroxide ions floating around, and then it's like a 10-step chemical equation you're going to be adding up. It gets quite confusing, and then you balance back and forth and electrons, and then you cancel out the hydroxides and hydrogens that are on the same side because it makes water. So we're just going to forget about that part for our course this year. Okay, so skip over that big fancy calculation, and let's move on to something a little bit easier. It's simply looking at one type of oxidation reduction reaction, and we're going to look at the whole equation. Okay, so here we go. You can definitely imagine this. What if I took a strip of aluminum, so aluminum foil, and I put it into a solution of 0.1 mole per liter of cupric chloride? Okay, obviously a reaction does occur. So let's write the balanced chemical equation for this reaction, including the states, and then we'll determine the oxidation number for each, and we'll figure out which metal got oxidized and which ion got reduced, and then we're going to show you what those half reactions look like. Okay, do you want to pause right now and try that balanced chemical equation? Back to normal balancing. Write out your equation, balance it like normal, but of course, if you've got your oxidation numbers on there, you can see what they would be. So we might as well do that too. Okay, so write your balanced chemical equation, fill in your oxidation numbers at the top, and then pick it up with me when you're done that. Okay, so I have aluminum, and I have my copper to nitrate. And this is a solution, so I of course know that it's going to be aqueous, reacting to produce some aluminum nitrate. That is a solution as well, and that gives me some copper solid. Okay, so you already can see there that you know your metal aluminum is going to go from metal atoms to metal ions, because you can see them as aluminum ions on the product side, can't you? Okay, so you can see how that happens. So now let's just confirm which one gets oxidized and which one gets reduced by putting the oxidation numbers on the top. Aluminum, 0. Okay, nitrates, remember I've got a 2 with a negative 1 charge, and I know that the copper here is +2. And I know that I have 3 nitrates over here, and then I know that my aluminum is +3. Copper solid is 0. So my aluminum goes from a 0 to a +3. Oxidation. I know that my copper goes from a +2 to a 0, and that's reduction. So here I go all the way over here, and of course we want to label that arrow as oxidation. Oxidation by a factor of how many electrons? From a 0 to a +3 is a factor of 3 electrons. Okay, 3 electrons lost. Copper goes from a +2 to a 0. That is a reduction. And again, a reduction because I've gained electrons, because it's gone from a +2 to a 0. My oxidation number has gone down by a factor of 2 electrons. Okay, so let's have a look at what that would mean in total. We'll go with Christmas colors. Got the Christmas tree set up in the back. Maybe by the next video I'll have some ornaments on it. All right, this is going to be a factor. Multiply this one by 2. Let's multiply this by 3 so that I have a total gain of 6 electrons and a total loss of 6 electrons. What was my multiplier? 3 and 3. And my multiplier up above was 2 and 2. And now I have a balanced chemical equation, and I did that using the oxidation numbers. You could have just done that by eye as well. Okay, complete the following table to summarize my oxidation and reduction half reactions. Then I'm going to show the net ionic equation. Which one got oxidized? the aluminum. How many? 2 aluminums. I'm going to put the states in here. As long as you're neat, keep them in, okay? You want to do that. 2 aluminums with a 3+ charge, and that was a loss of 6 electrons. My reduction half reaction is going to show my copper ions. So take my copper nitrate and split it up. Just show the copper ions. I could care less about the nitrates because you're going to cancel it on each side. I'm not going to factor them in anyway, right? I don't need those. But I do need to show my 3 copper 2+, and those are aqueous because they were in a solution. I know that I'm gaining 6 electrons. And what am I getting to? 3 coppers. Those were solids. Okay, my net reaction then, I'm going to cancel my electrons on both sides, and I'm going to just simply simplify my net reaction to say 3 Cu2+ plus 2 aluminum solids, giving me 2 Al3+ aqueous and 3 Cus. Does that look like copper? Is that neat enough for you? Okay. Now, here's a new term for you. Okay. I want to know which metal ion is going to have the greatest ability to be reduced. Okay, the one that gets reduced is going to be called the oxidizing agent. All right, so these are 2 terms we're going to come up with down below. One of them is the oxidizing agent, and one of them is the reducing agent. So here's how we figure that out. It's like, well, which metal got oxidized? Which metal ion was reduced? From that, we can figure out which one's called the oxidizing agent, which one's called the reducing agent, and that's pretty much how you can figure out which one will get oxidized or reduced if they're in conjunction with each other. In other words, does this reaction happen or not? Okay? So follow me along with this. This may sound tricky, but it's actually not very tricky at all. We know that this reaction takes place. If I put aluminum into copper nitrate, yeah, you get a chemical reaction. You can see it. I've written it out as a balanced chemical equation. It actually happens. The metal in the aluminum turns into aluminum ions, and the copper that was as the ions turns into copper atoms. And when I do this demo for you, you will remember this one because the copper actually comes out of the solution. Those copper ions are blue in a solution, and they're actually going to form copper solid sitting on that aluminum foil. Okay, so you can actually see that it's happening. This reaction does take place. All right, so now if we're just looking at the metal atoms and ions, I want to know, based on this chemical reaction that does occur, which one is called the reducing agent and which one is called the oxidizing agent. Okay, follow me? All right, so when the question says, which metal ion has the greatest ability in this equation to be reduced, your choices are Cu2+ or aluminum 3+. Those are the ions that we have available to us, right? These ones right here or these ones right here. Those are where the ions are because those are in the solution. So which one actually gets reduced? So which one has the greatest ability to be reduced? It's the one that actually does. So the answer is copper. Because when you put copper ions together, if they're in association with aluminum ions, it always will be the copper ions that get reduced as opposed to the equation going the other way around. It means this reaction does not go in the reverse direction. It will always go from copper ions to copper atoms. It will always go from aluminum atoms to aluminum ions. So when the question says which metal ion has the greatest ability to be reduced, it is the one that does get reduced, and so copper occurs. Okay, so how do we say that? What's our support to this answer? That the reaction proceeds in the forward direction. Okay, you go from Cu2+ to Cus and not the other way around. Okay? Okay, great. Got the message. All right, next. Vertically arrange these two half reactions of each metal ion and to show the increasing ease of reduction. This just simply means show which one will get reduced when you're comparing the two ions, okay? This is where we're going to be using some of the information in the textbook in a second, like in a little bit, in another lesson or so. And we're going to be looking at what's the difference between these ions, which one would get reduced, okay? And so the one that's most likely to get reduced, if you're comparing these two, is this one right here, because put together, it will get reduced. Okay, now here's where we take the term. So we need to figure out what this term means. And I'll tell you this. The oxidizing agent is the one that undergoes reduction. Okay, the agent is the one that goes under reduction because agent is like a helper. Okay, so that's what you want to think. You want to think this term agent means helper. Therefore, it helps the other substance get oxidized by itself becoming reduced. Okay, so which one is my oxidizing agent? It's the one that gets reduced. So the copper in the copper nitrate is the one that we call the oxidizing agent. Okay, so let's look at the second one. A reducing agent is one that undergoes oxidation. Why? Because if the reducing agent gets oxidized, it helps the other one be reduced. Okay, so go back to your chemical equation. Which one undergoes oxidation? It's this one. So what do we call it? We call it the reducing agent. And I know that that sounds a little counterintuitive, so I want you to just memorize that little definition. An oxidizing agent is the one that gets reduced. A reducing agent is the one that gets oxidized. So if you're given a chemical equation and said, which one's the reducing agent, you first have to figure out the oxidation number, figure out which one gets oxidized and which one gets reduced, and then by definition, which one's the reducing agent or the oxidizing agent. Okay, that's the only tricky part to this. The very last part of this question here just basically says then, if you were to look at the two metals to compare them to determine which one would be the best reducing agent, well, you're looking at the metal atoms, okay? So your choice are copper atoms or aluminum atoms. And which one actually gets oxidized if you have those two together? Well, we know that it's aluminum, okay? So most likely to be oxidized is aluminum because the reaction did occur. All right? And which metal ion is the best oxidizing agent? Well, I was again looking at Cu2 plus or Al3 plus. Okay, metal ions are aqueous, they're in a solution. And so which one? Well, the Cu2 plus is the best oxidizing agent because the reaction did occur. Okay, and it occurred in that direction, in that way, so then you know that when these metal atoms and the ions in a solution are put together, you know that this reaction will always be aluminum will react with copper nitrate, and if I put copper metal in a solution of aluminum nitrate, no reaction will take place because it's not strong enough. Okay, does that make sense? So we know that this reaction occurs because look, it actually shows us, and when I show you the demo, you'll see that it actually occurs. Okay, so that's it for today. That was a lot. I'll give you a few more questions to work away at, and tomorrow we'll look at, or the next day we'll look at doing a bit of a dry lab using this information. Okay, good luck.